This video is on factoring polynomials by grouping. The first thing you always look for when you are factoring is a greatest common factor. This four-term polynomial does not have a greatest common factor. I have a coefficient of 1 in the third term and no x in the fourth term, so there is no greatest common factor other than 1. The second thing you look for is if you have four terms, you can try grouping. And we do have four terms here, so that's what we're going to do. We're going to group this one. And usually you can just group the first two and the second two. Sometimes you may have to switch some terms around to make the grouping work out, but if it's written in standard form, most of the time you can group the first two and the second two and it's going to work out. Once you group it, you try to factor each binomial. The first binomial has a greatest common factor of 4x. So when I factor out 4x on that first binomial, I am left with x plus 2. Remember, you can distribute the 4x and you should be back to this binomial. 4x times x is 4x squared. 4x times 2 is 8x. The second one does not have a greatest common factor, so we're going to factor out a 1 and see if it works out for us. If we factor out 1, nothing changes. If we factor out -1, all the signs change. Now, what you're looking for at this point is for what's inside the parentheses to match. If what's inside the parentheses match, you've done it. So your answer is what you factored out, which is 4x plus 1 times what was left in parentheses that matches x plus 2. And that is your answer. If you fold this binomial or distributed 4x twice, distributed 1 twice, you would be back to the original question. So again, you are looking for, once you group it into two binomials, greatest common factor out of each binomial, you're looking for what's in parentheses to match. If what's in parentheses matches, that's one of your binomials in your answer. And what you factored out, in this case, 4x positive 1, that is your other answer. Or that's the other part of your answer. Your whole answer is 4x plus 1 times x plus 2. Here we have another four-term polynomial. No greatest common factor, so we group it. Now, when your middle sign is negative, you need to go ahead and change that to plus negative. You don't have to rewrite it like I did, but when you change subtraction to addition sign in the next number, that minus sign becomes plus negative. Then you group it, this term, these two terms, and these two terms. The first line on your paper can be right here. I'm just showing you the different steps. Over here, this can be what your first line looks like because you would have just put the parentheses here and here. Here you would have put plus negative, parentheses, parentheses. So your first line can look like this once you've done the two steps that I showed separately. Now I'm looking for a greatest common factor in my first binomial, which is n. When I factor out n, I am left with r plus 5. n times r is rn, n times 5 is 5n. On the second one, I don't have a greatest common factor, so I'm going to factor out 1 or -1. Now, if I factor out 1, I'm going to have negative r minus 5, which does not match. But if I'll factor out -1 and change these two signs, I get r plus 5, and now I have accomplished my goal. What's in parentheses matches, r plus 5. So what I factored out, n minus 1, is one of my binomials, and what was left in that matches, r plus 5, is the other. And I wrote this one different just to show you it does not matter what order you write them. Here I could have done the x plus 2 first, what was left in, and then what was factored out. Here I did what was left in, then what was factored out, just to show you it does not matter. Normally, I do it this way. What I factored out times what I left in. Here I did what I left in times what I factored out. Does not matter. Both are correct. Just be aware it could be written either way on a multiple choice assessment. Okay, think about number 3 and just think about what's the first thing you would do after you discover no greatest common factor. I have 4 terms. I'm going to try grouping. Think about what's the first thing you would do. The first thing you would do, because this middle term is negative, I need to change that to plus negative. And again, you would just do it right here, plus negative. Now, what's the second thing I would do? The second thing you would do is actually group it. And again, you're still on this top line. You change subtraction to addition, sign the next number, grouped, grouped. Now you got to start factoring out the greatest common factor. Greatest common factor on this first one is 9F. That leaves you with G minus 5. Here, my greatest common factor is 7. If I factor out a 7, I'm going to get negative G. So I'm going to factor out negative 7 so that I get positive G, and then I'll get negative 5, which matches. If I had to factor out positive 7, I would have negative G plus 5. So you may try it one way and see they don't match, and then try it a different way and change the signs, but I try to look ahead, so I only have to do it once. I knew if I factored out positive 7, I would have negative G, so I did negative 7. And now what's inside parentheses match. So my answer is what I factored out, 9F minus 7, times what matched in parentheses, G minus 5. Okay, I'm going to leave a couple of examples up, 1 and 2, while you try number 4. Number 4 says 6n cubed plus 8n squared minus 15n minus 20. See if you can factor that. First thing I noticed, my middle term is negative, so I change it to plus negative. Then I group first two, last two. Now, I'm looking for greatest common factors. And by the way, the first thing I did was notice there was no greatest common factor on all 4. But I do have a greatest common factor when I change them to 2 different binomials. On the first binomial, my greatest common factor is 2n squared. That leaves me with 3n plus 4. On my second one, I can factor out 5 or negative 5. If I factor out 5, 5 times negative 3 is negative 15. I need a positive 3, so I'm going to factor out negative 5. And that leaves me with positive 3n and positive 4. So what's in parentheses matches? So I'm done. I just write my answer. What I factored out, 2n squared minus 5. And what was left in that matches, 3n plus 4. And again, I could distribute, or FOIL all that out. And I'm going to end up back up here with a question if I did it correctly. Try number 5. On number 5, I have no greatest common factor. My middle term is negative, so I change it to plus negative. Then I group the first 2 and the last 2. And again, this is the first line on your paper. Now I group each binomial. The first binomial has a greatest common factor of 5n squared. That leaves me with 2n plus 3. The second binomial, I can factor out 6 or negative 6. If I factor out 6, I'm going to get negative 2n, so I'm going to factor out negative 6 so that I can get positive 2n, and these two will match, which means these two will probably match as well. Negative 6 times 2n is negative 12n, negative 6 times 3, negative 18. So I've done it. What's in parentheses matches. So that's one of my binomials in my answer. The other is what I factored out, 5n squared minus 6. You have to be able to know how to factor using greatest common factor before you can try factoring by grouping. So that's why greatest common factor is taught first, then you learn how to do it by grouping. All right, we're going to do one more before I add a new wrinkle. So try number 6. On number 6, again, my middle term is negative, so I change it to plus minus or plus negative. Group the first 2 and the second 2. Now I'm ready to factor the greatest common factor out of each binomial. The greatest common factor on that first binomial is 4n squared. That leaves you with 6n plus 5. Something to check for, once you factor out a greatest common factor and you see what's left, make sure there's no greatest common factor left in parentheses. If there is, then you didn't factor out the greatest common factor. You just factored out a common factor, but not the greatest. For instance, if I had factored out 2 right here, I would be left with a 12 and a 10, I think. So not quite done. If I had 12n plus 10, that's not factored completely. Still have a common factor of 2. So make sure you're factoring out the greatest common factor. In this case, it's 4n squared. On the second one, I can factor out 3 or negative 3. I'm going to have to factor out negative 3 so that I'm left with positive 6n, positive 5 to match. And your answer is what you factored out, 4n squared minus 3, times what you left in, 6n plus 5. I'm going to do number 7 as an example because it's different. Not only do you have really big numbers, but there's going to be a new wrinkle to this one. So you always look, can you find the greatest common factor? Well, I cannot factor out an n because the last term doesn't have one, but all of these are even numbers, so I know I can factor out a 2. Now, if you have your own method for finding greatest common factor, use it, but you're trying to find the greatest common factor between 216, 180, 144, and 120. A method I'm going to use is I'm just going to do the smallest number I can possibly do and see what happens. If I factored a 2 out of these 4 numbers, I can cut them in half in my head very easily to 108, 90, 72, and 60. These are all even numbers, so I know I can cut them in half again. So if I factor out another 2, I have 54, 45, 36, 30. I have an odd number, so I cannot factor out another 2. But let me think, is there anything else I can factor? 9, nope, 9 won't go into 30. Let's check 3. By the way, to know if 3 goes into the number, if 3 will go into the sum of the digits, then 3 will go into the whole number. 5 plus 4 is 9, 3 will go into 9, so 3 will go into 54. 4 plus 5 is 9, 3 will go into 9, so 3 will go into 45. 3 plus 6 is 9, so 3 will go into there. 3 plus 0 is 3, 3 will go into 3, so 3 will go into 30. So my greatest common factor now, or a common factor at least, is 3. If I divide them all by 3, I have 18, 9, 12, and 10. Now I'm looking for a common factor between these 4, cannot find one. So I went through 3 steps to figure out that my greatest common factor was 12. 2 times 2 times 3 is 12. If you've got a better way to find a greatest common factor of 12, by all means do it. But I need to come over here and factor out 12. If I factor out a 12, I am left with 18n cubed, negative 15n squared, positive 12n, and negative 10. And again, if I distribute this 12 4 times, I should be back with the original question. So what was different about this one is I can factor out a greatest common factor from all 4 terms before I do the grouping. Now I'm ready to group. When I group, I'm going to, well, I didn't, hold on just a second here. Okay, I did not show this one grouped, so I'm going to group it right here. So first 2, second 2. Now I'm factoring out of this 18n cubed minus 15n squared. The greatest common factor is 3n squared. I'm left with 6n minus 5. 3n squared times 6n is 18n cubed. 3n squared times negative 5 is negative 15n squared. I'm just going to leave this 12 over here hanging out for later. Now I factor the 12n minus 10. My greatest common factor there is 2. When I factor out 2, I'm left with 6n minus 5. I match 6n minus 5, 6n minus 5. So what I factored out, 3n squared plus 2 times what was left inside that matched, 6n minus 5, and I bring down this times 12 that I had hanging out over here. Now it is fully factored. So in review, the difference was I had a greatest common factor, I factored it out, then I left this 12 and I brought it all the way down to the end, but I ignored it as I grouped here and here, factored it out, and then I brought the 12 down at the end. And again, how you find that the greatest common factor is 12, if you've got a better way, that's fine as well. Okay, this is our last one, so I'm going to let you try it. 180n cubed minus 240n squared plus 150n minus 200. I hope that a common factor is very obvious to you. They all end in 0. So what's the greatest common factor? 10. And maybe I shouldn't have said greatest common factor. I'm not sure, but I know it's a common factor. A common factor is 10. If I take 10 out, I can get rid of all 4 zeros. And I'm end up with 18n cubed minus 24n squared plus 15n minus 20. Now I check, is there another greatest common factor? Is 10 the greatest, or do I have another one to make 10 greater? 18, 24, 15, 20. Nothing will go in all 4 of those numbers, so I'm good. 10 is my greatest common factor. So now I group, and I factor out this binomial and this binomial separately. And I'm going to leave that 10 hanging out to drag down to the bottom. On this first binomial, my greatest common factor is 6n squared. 6n squared times 3n is 18n cubed. 6n squared times -4 is -24n squared. Now I'm looking for a greatest common factor on the second binomial. It's going to be 5 or -5. If I take 5 out, I'm left with 3n minus 4. That works. They match. So I'm almost done. I have my matching binomial, 3n minus 4. What I factored out, 6n squared plus 5 is the other binomial. And I bring down this 10. And there's your final answer. So in review, always look for a greatest common factor first. I did. I factored out a 10. Then I had 4 terms with no greatest common factors. So I grouped the first 2 and the second 2. Factored the greatest common factor out of each binomial. If what's left in parentheses matches, then you've succeeded. And your final answer is what's left in parentheses that matches is one binomial. What you factored out is the other binomial. And in this case, if you originally factored something out of all 4, it's got to come down as well. And that is our video on factoring polynomials by grouping. Thank you.